Okay, starting off with my reaction, calcium chloride, sodium iodide, calcium chloride, CaCl2, sodium iodide, NaI. I used charges and crisscross to find those. Switching my positive ions, because this is a double displacement. Sodium is going to be with chlorine. They're both plus ones. Calcium is going to be with iodine. Again, looking at my charges and crisscrossing. A 2 here balances my iodines. A 2 there balances my sodiums and my chlorines. Now, I have grams of 2 different things, which means I can find moles of 2 different things, which means this is a limiting reactant problem. So I need to do a nice chart. Right off the bat, I can make these zeros because we don't have any products before the reaction begins. And they are going to increase with their coefficients over the course of the reaction. Using the grams that I have to find moles, for calcium chloride, grams equals moles times the molecular weight of CaCl2. So 40 plus 35.5 times 2 gets me a molecular weight of 111. This gets me my moles of calcium chloride to be 0.135, which can go here. For sodium iodide, grams equals moles times molecular weight of NaI, 23 plus 127. Molecular weight's 150. So my moles of sodium iodide are 0.267, which can go here. These are both reactants, so they are both going to decrease, again using their coefficients as the number of x's. To figure out which one's limiting, I go off to the side and I'm going to divide each of these moles by their coefficients. So for calcium chloride, 0.135 divided by 1 is still 0.135. For sodium iodide, 0.267 divided by 2. And if I kept that number on my calculator, these numbers are really close, but it's 0.133. Slightly smaller, so if you're getting the exact same numbers, maybe at least leave this to 3 decimals. Or go back and do 40 divided by 150 in your calculator. Use that whole number divided by 2. So this one's slightly smaller, which means it's my limiting reactant. It runs out, it goes to 0. I use that column, the one that runs out, to find my x value, which is 0.133. That x value gets plugged in all of these places. 0.135 minus 0.133. 0.002, 0 plus 0.133, 0 plus 2 times 0.133. If you're using it in your calculator, you'd get 267. If you're just using 0.133, you'd get 266. Doesn't matter for me. My whole ice chart's done. It wants the mass of calcium iodide produced. So calcium iodide, those are my moles. Grams equal moles times molecular weight, which is 40 plus 127 times 2. Molecular weight is 294 times 0.133 per grams. We get about 39.1 grams. If you didn't realize this was a limiting reactant problem, since those numbers are so close, you probably lucked out and got the right answer or a close enough answer anyways. But ideally, you knew it was a limiting reactant.